Okay, so now let me welcome you to the test rollout of the DLT4ALL project that will include the learning modules number 2 and 3 of our program on encryption techniques and consensus mechanisms. Our intention in doing this test rollout is to check the materials that we are creating within the project. So we want to encourage all the participants to give us your feedback about how the course is developing, about what is your opinion on the materials and the delivery of the course, because this will be very useful for us in order to put the final touches on the final program that will be delivered. The complete course will be delivered during this next autumn and winter in different places all around Europe, and you will also have the opportunity to follow the full course in the future if you want also. So without further ado, let me just introduce you to Professor Sula Luca from the University of Nicosia. That is the institution that is the coordinator of this DLT4ALL project. And she, with Professor Elias Joseph, would be in charge of teach what we call the learning module 0, that is the introduction to the course, and also it tries to be like an introduction to the world of the DLT and blockchain technologies, especially for all of you that are less acquainted with the subject. So Sula, the floor is yours.
Thank you, Manuel. As Manuel has already mentioned, this is the introductory course to the series that we have. We will be discussing a little bit more on that. I will be delivering this module with my colleague, Elias Joseph. So I will start with a short intro to the whole DLT4ALL course, which is actually comprised of 8 different modules, plus this introductory course. Even though in the project we had initially discussed the 8 courses, we thought that instead of giving an introductory section in all the different courses on blockchain technologies, and that would overlap with all of them, we decided to just have a separate module for them, with anyone who doesn't have a background in blockchain technologies and DLTs to follow that one first, and then the rest. So this module is actually divided into 2 logical parts. In the first part, we will be introducing the DLT4ALL, identifying the target audiences, and the part of the curriculum that we are addressing. In the second part, we're going to give an overview of the blockchain technologies, based also from a historical perspective and from a technical point of view as well. A taxonomy of the blockchains based on the reading and writing permissions will be given, as well as discuss the concepts of cryptocurrencies, smart contracts, and decentralized applications. So, in this module, our learning objectives will be, as we already mentioned, to present the content of DLT4ALL courses. It's just one course actually made of 9 modules, define our target audiences, describe the certification options that will be available to the participants, because at the end, once this course is completed successfully by someone, they are eligible to a certificate that will be issued on the blockchain. In addition to that, we are going to have an overview of the technological components of a blockchain-based system, and present us, as we already said, a characterization of the blockchains, describe the concepts of cryptocurrencies, decentralized applications, the smart contracts, and present a couple of relevant use cases, even though various use cases will also be presented throughout the rest of the modules. By the end of the 2-3 hours that we have ahead of us, it is expected that you should be able to understand the historical development of blockchains, what the DLT4ALL course is made of, the technical components, concepts of cryptocurrencies, and so on, and describe also a number of blockchain use cases that blockchain technologies are useful to be applied. So without any further delays, I will go actually to the overview. How this project started actually, the DLT4ALL project, it was back a few years ago when we identified, the consortium has identified the lack of knowledge by many of the potential benefits that organizations have when actually adopting these technologies. We realized that there was quite some scattered knowledge all over the internet. The University of Nicosia was at the time offering already a master's degree in blockchain technologies. So we thought that it would be a good idea to put together a curriculum that would be available to everybody interested in the technologies to learn more about how they could be using them in their own field, in their own discipline. We are using a mixture of means from actually classroom learning, even though this is kind of difficult to do now with the whole situation with COVID, because we have planned for face-to-face lectures as well. And in fact, this one was also supposed to be face-to-face. Unfortunately, with the current situation that we have worldwide, traveling and meeting face-to-face is not possible at this point in time. So we are focusing on delivering this material online. If you have any suggestions on how we can actually bring the face-to-face, let's say, touch within the online, please feel free to convey your ideas to us. So we will be using a MOOC-style online learning for most of these modules. In some countries, we're hoping that we would be able to deliver also some face-to-face as well, for maximizing the impact and the benefit for our target audience. The target audience is actually a variety of groups of people ranging from university students and researchers, entrepreneurs that are active in startups, high-tech SMEs, early-stage investors, and incubator managers. I would like for you to pause for a second and think, where would you classify yourself? Afterwards, actually, we also have a questionnaire that this question is also being included, and it will be very useful to us, for us to identify the target groups in which our participants for these different modules come from. So, As we already mentioned, the whole course structure is comprises of 8 thematic priorities, plus the module 0, which introduces blockchain technologies. The rest of the courses that we have are peer-to-peer database design, encryption techniques, consensus mechanisms, digital structures, property rights, smart contracts, distributed autonomous organizations, blockchain-based decentralized applications. Okay, let's go to the next one. As we already mentioned, upon the successful completion of all the modules, the learner will be able to receive a certificate of accomplishment that will be issued by the University of Nicosia, because we have actually the application for issuing certificates on the blockchain, and signed by the consortium. Let me move into now the second section, which is actually our main material, sections 2, 3, 4, and 5. So in this section, we are going to have an introduction to blockchain, give a historical overview, discuss the various technological components of a blockchain-based system, and at the end of the section, we have some references for further reading for you. Also, at the end of the whole module, we have a sample of questions that, provided we have enough time, we can cover them together and provide the correct answers. So, when it comes to blockchain technologies, blockchains, it is a relatively new technology. It was introduced back in 2008 as the technology underlying Bitcoin, the cryptocurrencies, Bitcoins. It was invented initially to support this cryptocurrency. So we can look at actually Bitcoin as the first application for blockchain technologies. Soon afterwards, industries recognized the potential of the technology, and they started exploring several applications for improving their current practices in terms of processes that they were using in their organizations, or create new ones that were not possible till then. If we look at Bitcoin as such, we can describe Bitcoin as a decentralized, private, digital cryptocurrency. We say decentralized in the sense that there is no issuing party. If we look at fiat currencies, euros, dollars, British pounds, and so on, these currencies, they have usually a government, for example, behind them. In this case, there is not an issuing party, and the units, they are issued algorithmically. Digital, due to the fact that they are fully electronic with no underlying peg assets, and cryptocurrency, due to the fact that it's anti-counterfeiting through cryptography. And we're going to discuss what is actually cryptography and how this is done. So Bitcoin was actually two innovations. The first innovation was the fact that it is a store of value for people who wanted an alternative to the existing financial system that we are even using today. And it was also at the same time a new way to develop open, decentralized networks. Decentralized networks in the sense that all the various intermediaries that we have are being removed. So it is a peer-to-peer network without trusting unknown parties. Before we go into these details, let us see brief historical overview of blockchain. By the way, I'm not sure if there are any questions, but I suggest we take questions perhaps after the end of the specific section. Okay, so that we can pause for a while and take the questions and then continue. So, as we already said, Bitcoin was introduced back in 2008 by Satoshi Nakamoto, even though nobody knows who this person is actually. It's a pseudo name. And when he published the white paper, Bitcoin, a peer-to-peer electronic cash system, in which he introduced Bitcoin. 2009, the first Bitcoins were mined, and the first Bitcoin transaction took place when Nakamoto sent to Halfini 10 Bitcoins. In 2010, this part is very interesting. A Bitcoin user buys 2 pizzas with 10,000 Bitcoins. These 10,000 Bitcoins today would worth something like 80 million euro. At the time, it was just, imagine, it was just maybe a few cents for each Bitcoin. The price today is close to 9 to 10,000 euros per Bitcoin. In 2011, 1 Bitcoin was equal to $1, and other cryptocurrencies started to appear, such as Litecoin. 2013, we have the first Bitcoin fork. It happened because the Bitcoin holders would not agree on the various transaction rules, and as a consequence, the network was split into 2, and both of these networks were running in parallel. 2014, we have one of the major, let's say, frauds that happened, and Mt. Gox goes bankruptcy. Mt. Gox was an exchange in Japan, and it went bankrupt for several reasons. And investors basically lost a lot of money. The following year, more cryptocurrencies emerged, including Ethereum. And the interesting part about Ethereum was that it was the first time also we would see smart contracts coming around. 2016, cryptocurrencies continued to rise and become more and more popular. And various organizations around the world start accepting Bitcoins. The Swiss Railroad accepts Bitcoin payments along with several other ones. Actually, I should have mentioned it earlier, that back in 2013, the University of Nicosia also started accepting Bitcoins, and it was at the time the first university in the world to accept Bitcoins for tuition fees for the students. Moving to 2017, another fork occurs, which splits again Bitcoin into 2. 2018, various EU governments joined forces to develop a legal framework for cryptocurrencies, and 19 cryptocurrencies and onwards, the cryptocurrencies become more and more accessible to users. Let's discuss now a little bit on Bitcoin basics. One might ask, is Bitcoin a currency? Well, it is a form of digital currency, and it was the first example of a cryptocurrency. As we said, it was created and held, it's digital, and it's held, of course, electronically on a computer, produced all over the world using advanced computer software that solve mathematical problems. They are not paper money like dollars, euro, yens, whatever, that are issued by central banks or other monetary authorities. They're private in that they are not issued, as we said, by a state authority. And it is also a pan-global means of exchange. It's a global currency, in other words. And transfers are made via computers immediately with low transaction fees. It's not possible to have fake coins, fake cryptos, due to the fact that anti-counterfeiting is possible through the cryptography, the strong cryptography that they are using. Why is it a global means of exchange? Bitcoin, it is a fixed asset. It only a total of 21 million coins will be produced. Central banks or monetary authorities do not control the number of Bitcoins that are being issued. And this is controlled actually by the actual network itself, the way the network is designed. It is decentralized, making it global. Anyone with a computer around the world and an internet connection can set up a Bitcoin address to receive or transfer Bitcoins in seconds. Even though they say that Bitcoin is anonymous, I wouldn't say that it is anonymous as such. I would call it more as pseudo-anonymous. It's not easy to identify who are the Bitcoin holders, even though nowadays there are companies around the world that are working towards identifying the flow of cryptocurrencies and who sends what. Chain analysis, for example, is one of them. And they're collaborating with organizations such as the law enforcement to identify illegal activities for Bitcoins, just like, of course, there are illegal activities with any other currencies, the same with Bitcoins. It is the DLT4ALL, the DLT technology, the decentralized technology that makes it transparent, and it allows users to maintain multiple addresses, and setting up an address actually requires no personal information. Bitcoin is divisible, so that its growth, it has a large growth potential as an exchange medium. In 2015, the Commodity Futures Trading Commission in the United States officially designated Bitcoin as a commodity. So this is why one can say that it is a currency and it is a global one. Bitcoin, one can also say that is actually a product of the technological revolution. It is semi-anonymous, used by people all over the world as a medium exchange without involving governments. And it offers a method to transfer wealth to regions to the world where restrictions are less. Okay, let's move. Now, a little bit on how actually a blockchain-based system works. What is blockchain? We can look at blockchain as a distributed ledger of any type of transactions. First, we need to understand what is a transaction. We can look at a transaction as exchange of data between two different parties. The data could be financial data, could be consumer details, could be medical data, could be product data. So exchange of data, definition of a transaction. It is shared. In other words, blockchains do not make much sense unless two more people or parties are involved. We have to have a network, in other words, of different parties. The transactions, they are stored in chronological order, exactly when they occurred. Another important aspect is that you can only add transactions to a blockchain. You cannot delete them. And once you have a transaction there written on the blockchain, you cannot delete it, you cannot change it, just like we would do in a database, let's say, in a regular database. They are cryptographically secured, and this is enabled by advanced cryptography, and also it enables smart contracts. Smart contracts, we can look at them again as programmable contracts, code, that these contracts, they become active, effective, when the conditions for which they were programmed for are met. Now, if we look at the blockchain-based system in a more graphical way, in the first diagram, we see what we refer to as a centralized ledger. Imagine you have a bank, and this bank, in order to exchange and to have any transactions taking place between them, we need to have a clearinghouse, an intermediary, where a centralized ledger is kept and the transactions, to enable the transactions to take place between these different banks that we have. In a decentralized system, in a distributed ledger, in other words, each of the banks keeps a copy of the ledger by itself. So if a change is made, all the different banks have to confirm, accept the change, and make the change in their copies that they have as well. We're going to see this in a little bit more detail. Now, going back to the definition of a ledger. What is actually a ledger? We can look at it as a recording of all different types of transactions that take place in a business, and it reflects a permanent summary of all the amounts that were entered in some sort of a journal, listing the individual amounts by date, by amount, by time, and so on. Examples may include citizenship records, bank accounts, transactions that take place with credit cards, accounting ledgers, land registers, hotel guest reservations, and many more. So, all right. In a ledger, we cannot allow anybody to enter a transaction. So that is why we do not allow anybody to be able to modify the data. Imagine our medical records. What if anybody could go just have access to our medical records or to our bank accounts, as a matter of fact, and be able to modify our bank accounts and the data that is there? So in a centralized system, for these different types of modifications to take place in medical data or in bank accounts, especially in financial transactions, a trusted party is required that is in charge of all the different ledgers. And many times this is hard to find this trusted party. Blockchains, when it comes to blockchains, they enable unknown parties to transact with each other without actually trusting each other. So the transactions cannot be censored. The transactions cannot be modified by the record keepers. And this is why we trust these unknown parties, because we know that they will not be able to modify them unless everybody in the network agrees for the modification. And this is usually, of course, hard to do. And also because of all the transactions are cryptographically written in the blockchain. And transactions, of course, they cannot be lost. So blockchains, we can say they eliminate the need of a central ledger. They consist of blocks that they hold batches of valid transactions. What we mean here, as we're going to see in the following slides, the transactions, whatever transactions take place, are written in a block of a certain size. Once that block is completed, then we move to the next block. And this is how a chain is being formed. They can be open, verifying anonymous actors in the network, or they can be closed and require actors in the network to be identified. This is, we will further explain this in the following sections when Elias will be discussing with us the public and private blockchains. The main idea is that there is no central record of transactions. Instead, many copies of the ledger are distributed around the world. And each owner of each copy records their transactions. Let's look at an example. Okay, universities start soon, and parents will need to pay the rent for their kids that are studying abroad. And so we have this example. Helen, the mother, wants to send some money to her daughter, Mary, who is studying abroad, as Mary needs to pay the rent to the landlord. And the rent is actually €400. Of course, the mother will send some extra money to the daughter for the rest of her expenses. Now, the first thing that happens is that, as we see here in the bottom block, where it says that Helen has €10,000, the bookkeepers will check if Helen has enough money to send to her daughter. We see that Helen has actually 10,000. She only wants to send 1,000. So this is okay. She can do it. So they approve this transaction. In the green block, we see the current situation actually of each of the three parties involved. We see Helen with the 10,000, Mary having only, as a student, of course, usually she spends her money down to the almost the last penny, €100, and the landlord has €20,000 in his account. So we said that the bookkeepers will check if Helen has enough money to carry the transaction, and if okay, she sends the money. So in the second part here, Helen sends Mary the €1,000. Helen is left with €9,000. Mary has in her account now €1,100, and the landlord, because the second transaction has not taken place yet, only with his 20,000. Now, there is no way a fake transaction can make it, because if we try to alter the ledger, remember that the way this is shown here is being kept by all different parties in the network. So if we try to change one of them, the rest of the parties will not agree. So a modification cannot take place. Mary now has received the money. She will send, again, the bookkeepers will check that indeed Mary has enough money to send the €400 to the landlord, and the transaction will take place. The second transaction will take place as well. So current situation after both transactions take place is that Helen is left with the 9,000, Mary with 700 because she has already paid the 400 to the landlord, and the landlord has the rent plus his money that he already had in his account, 20,400. Some buzzwords that we need to know. Bitcoin. What you need to remember here, when it comes to Bitcoin, you may see it with a small b being written or with a capital B. With a capital B, it describes the concept of Bitcoin or the entire network itself, the Bitcoin blockchain, in other words. When it comes to small b, we describe the unit of account, the cryptocurrencies. Address is a location that Bitcoins have been sent to and reside at. Alternatively, this can be thought of as an account of sorts that has a balance of Bitcoins. So in this address, I have, let's say, three Bitcoins. Blockchain, the complete transaction ledger of the Bitcoin network or any other actually cryptocurrency, showing how Bitcoins have been transferred from one address to another over time. The other thing that we need to remember is that a blockchain is actually a public record of all the transactions in chronological order. And if you go into Bitcoin Explorer, you are going to find, for example, there, all the different transactions that have taken place since The first one back in 2008, 9, whenever that, and 2008. Of course, we're talking about tons of data there. Transaction, as we already said, the exchange of data that represent any type of data, medical data, consumer details, financial data, and so on. As we said, Bitcoin is not the same as blockchain. Bitcoin is a currency, even though there is one blockchain that is called also Bitcoin, the one that issues the Bitcoins, the cryptocurrencies. Its underlying structure is called blockchain. And blockchain can be used, as we're going to see, in many other applications. They establish trust between parties that do not trust each other, removes intermediaries, and it is in fact a decentralized system. I would like to go over some more definitions and explanations to understand the whole thing here as we move forward. Hashing. What is actually hashing? I'm sure that some of you have heard this term before. Hashing is when we apply an algorithm to generate a value or of some sort of string using a mathematical function. Every time you apply a hash to some data, provided, of course, it's exactly the same data, you're going to get the exact same hash value. They are what we refer to as one-way hashes. In other words, I can only do the hashing and get the string, but it's hard, if not impossible, to go back and get my initial data. So if you have the data, you can find the hash, but if you have the hash, you cannot figure out the data. And this is what makes part of what makes blockchains hard to break. Anti-counterfeiting. As a note, we are going to mention that Bitcoin actually uses the algorithm called SAH-256 hash and is presented by 64 hexadecimal characters. Each one of the 32 bytes is represented by 2 hexadecimal characters. I have a link also here. Let me try to go over it. And this is actually there. If you look into the internet, into the web, you're going to find multiple sites that they have several hashing algorithms for which you can test and see what types of hashes can be found. Let me try to initiate this. Can you see the screen, please, now with the web? No.
No, we cannot. You have to stop sharing the presentation screen and share the other screen, the web screen.
So let's see how we can do that. All right, I cannot see the buttons here. Oh, wait a minute, I thought I stopped sharing. And I share it again. Share. And I want to go this one here. Can you see it now?
Yes.
Great. So let's say these are various types of hash algorithms that we have on this side. So let's say that I was already testing it yesterday. All right, I will use the same phrase, hello world. And if I use the SHA-256 algorithm, this is actually what I will end up. So my message was hello world. I end up with this hash here. If I do a slight change, let's say I change this. Wait a minute, let me make sure that you can see the whole thing. All right, now I think you can see it. So let's say that I change this to a capital H. Immediately, the thing changes. Now, we say that it is a one-way encryption because if I am given this hash, I cannot actually figure out easily that this is actually my data. Okay, so you have this algorithm in the slides, this website in the slides. You can play with that at a later time. So let me stop sharing again and go back to the presentation. Share, and I go here. Oops, all right. I guess it went back in the beginning. Sorry about this, I need to find where I was. Okay, I think this is where I was. Okay, now, there is also another term that I would like us to know. It is important that we do know this. A nonce. A nonce, it's a number usually that it is used once. It is added to a hashed and encrypted block to meet even more difficulties when it is rehashed, so that we don't get the same one again. So, and usually the miners, they're looking to solve these nonce to say that they actually solved the problem that they have at hand. Cryptography. Cryptography is actually the practice of developing various protocols that prevent third parties from viewing that data. And actually, cryptography is it's not something that started the past years with technology. For example, Caesar was using the famous Caesar cipher to securely communicate with his generals. And if you think about it, it was something very easy that was done, but still the message was scrambled so that anybody intervening with it would have a hard time to identify how this was done. And for example, it was just to shift the message by 2-3 letters. So, for example, if anybody wanted to send the letters A, B, C, and let's say it would shift them by 2, A would change to C, B would change to D, and C would change to E. I got them right. So, of course, we have cryptography, as we said, for preventing people to view our private data. And modern cryptography nowadays combines the disciplines from mathematics, computer science, physics, engineering, and more, and it makes decryption even more difficult. So, terms to remember is encryption, encoding, in other words, the text into unreadable format. Decryption, resolving encryption converting the scrambled message back to the original form, and we refer to as cipher the algorithm that we use to perform the encryption or the decryption. Now, we've mentioned the term blocks earlier. Let's explain a little bit better what we mean by that. Blocks, they're actually, when we have a transaction, all these different transactions that are being carried out, we put them together in batches and we put them in a block that we keep them all together. And once a block is filled out, we move to the next block. The blocks, they are connected with each other by one-way hash. And this is how we get actually the block of chains, a blockchain. So a block may contain multiple transactions. Once a transaction record is added to the chain, they cannot actually be modified. And transactions, they're validated by the network participants and recorded in chronological order, as we said. There is a timestamp on every transaction and protected by these one-way cryptographic functions. All right. So the way blockchain works, we said that it is a decentralized ledger, and that enables the recording, the storing, and the sharing of cryptographic data that represent the transactions across multiple ledgers. Each ledger has the same information and is being kept by a network of nodes that we may call them also servers or peers. No intermediaries are involved. There are no humans, and as a consequence, we eliminate also the human error, since everything takes place algorithmically. Data are stored cryptographically in the blocks, and consensus algorithms, we will also be talking a little bit more on consensus algorithms. They're responsible for creating and verifying this structure, which is actually growing continuously. As more transactions take place, obviously, more blocks will be created all the time, and the whole structure is growing. A-level consensus algorithms. Consensus algorithms, they can be considered as the mechanisms by which a blockchain network agrees on a transaction. They reach consensus, in other words, whether they will accept or not accept a transaction. In public blockchains, decentralized ones, they're built as distributed systems, and since they do not rely on a central authority, the distributed nodes, they need to agree, as we said, on the validity of the transactions. The consensus algorithms, they're actually a very crucial element of every blockchain network, as it is these algorithms that are responsible for maintaining the integrity and the security of these distributed systems. They provide, in other words, the means of distributed nodes reaching consensus on which version of the blockchain is the real one. They agree upon the current blockchain state. And this is something that is essential for any digital economic system to work properly. Different types of consensus algorithms. We are going to mention a couple of the most important ones, even though new and more algorithms come into place by researchers that are working on these types of algorithms worldwide. The first one that we're going to discuss and is the proof of work that it was actually the first consensus algorithm to be created. And it's employed by Bitcoin. And of course, that's why it was the first one. Bitcoin was the first blockchain. It is as an essential part of the mining process. And it involves various, and a number, actually, a large number of hashing attempts. Lots of hashing attempts means, of course, a lot of computational power that needs to be consumed. So miners with a high hash rate, they have better chances to find a valid solution for the next block. In other words, miners that may hash a large number of hashes within per unit time. The proof of work algorithm makes sure that miners are only able to validate a new block of transactions. And once that block of transactions is validated, then they add it to the whole blockchain. And the network grows bigger. Another interesting consensus algorithm is the proof of stake, developed in 2011 as an alternative actually to proof of work. The proof of stake replaces the proof of work mining with a different mechanism in where blocks are validated according to the stake of the participants. In other words, the validator of each block is determined by the investment of the cryptocurrency itself and not by the amount of the computational power that is allocated. Differences between the two. In terms of the proof of work, the probability of mining a block depends on the amount of work the miner does, and it consumes much more energy than the proof of stake. In the proof of stake, stakeholders mine new blocks by utilizing their own share of coins on the network, and a user needs to have a majority of all coins in order to be able to attack the network. And this is kind of course, difficult to do. This brings us to the end of the second section as well, on the technological components of blockchain. And I will pass now the floor to my colleague, Elias. So I'm going to stop sharing the screen. Of course, if there are any questions, we can take them along with Elias. Elias, do you want to get online also?
Hello, Sula. Thanks, Sula. Can you hear me?
Yes, of course.
So I think that I need to be the presenter, also starting
Yes.
the video now to check also my video quality. Can you hear me well?
Yes, we can see you and we can hear you.
Mm-hmm.
Correct.
Great. So before taking with you any questions about the previous sections, section 1 and 2, I would like to ask about the technicality of this live session. Is it possible to enable a chat room which is visible by everyone in order to initiate a discussion in between us, meaning the presenters and the audience? I mean visible, I refer to the ability, one question posted by anyone to be visible by the rest audience. This way, I hope to have an interaction, focusing on the questions and the discussion.
I just sent a message. Can everybody see it? I said, hi all.
No.
I send it to everyone. Valentino, can you enable this chat? Can you?
I think that's enabled.
So let's do
you need to select everyone.
Mm-hmm.
Yeah,
let's do the following test.
No, can you check now? Or the Q&A section.
I'm seeing a hello everyone, a hi all from Sula and Valentinos.
Yeah.
We need to check that this functionality is also provided to the attendees, because I think that the presenters and the host by default have this right.
Yes, so attendees, please inform us if you can see.
Making this check because I think that Sula's presentation gave an excellent background upon which we can do things, two things. First, deliver the rest of the material, which is based on these foundations, and do that in a way that is based on some questions, short discussions, etc. So I invite all attendees to say, send a hi.
I just received a message from Joss that they can see the chat.
Okay, great.
So I think so. It's time to take questions on the previous sections before moving to section number 3, characterization of blockchains.
Mm-hmm.
So,
if there are any questions, we'll be more than glad to answer them.
I can do initiate this by saying these questions. It goes to all. What do you think is the probably most important in terms of global impact application of the theory as well as technologies just presented by Sula? Any ideas about a great application or something?
Do you know my personal opinion?
Yep.
All right, then, since. Well, you know that I have been involved in these different types of technologies for the past 6 years. And actually, if I didn't believe in them, that they can actually transform the way that a lot of the different processes that we have in businesses and various organizations dealt with, I wouldn't have spent so many years on them and, you know, continue even more. So in my personal opinion, actually, I believe they will have a very large impact on almost every type of business that are using massive amounts of data that need to be trusted, and data that are transaction-based ones.
Thanks, Will. I fully agree with your view. I would like also to hear any other opinions or comments on that from the attendees. Any comments? How to make this question more specific? How do you see the potential application? Of course, at a certain degree for your individual case in your professional, very specific professional environment. This is another way to ask why do you consider blockchain technologies being one of the main emerging technologies? And I would like to say for just later this characterization emerging technologies, because I think it is important to make to emphasize one main characteristic of this term. So going back to the original question, initial question, what type of applications do you foresee being likely for your immediate professional environment? Any ideas here?
Sorry, Elias. I've seen that one of the participants has intervened in the Q&A. I don't know if you can see it.
No.
I cannot see it either.
I can see it.
So,
in the Q&A, one of the participants has answered.
No. Okay. So it is useful also for another reason of doing this to make sure that we have
Valentino, we cannot see
access to this.
I see the answer in the slide.
What, Valentino? We cannot see that.
You need to open it from
the QA.
Yeah.
There's some buttons at the bottom of the screen.
Okay, yes, I see that. Maybe supply chain applications. I agree with Arturo. I believe supply chain is one of the major areas in which blockchain technologies can be applied. There are already several use cases. I will briefly describe some of them at the end, actually, that have a couple of them at the end that have been implemented in relation to supply chain.
Also agree. Let me also, another technicality, sorry for that, I cannot see the supply chain related chat.
And
I have
click on Q&A.
Yes, I did that. I'm seeing only a post by Luis Ma saying no.
Scroll down a little bit.
Probably it was sent to no. Nothing visible to me.
Simona has just sent something I thought, but I lost it. I saw it briefly when it came on the screen, and then I lost it.
I can see Simon message in the chat. It's in the chat section.
Okay. All right, yes. The main use case is trust with absolutely, Simon, I agree with you. One of the main uses is that yes, they do provide trust without a central authority. They are removing these intermediaries that we used to have till now. For example, using our credit card, usually banks, in order to trust the credit card from any organization, to trust a credit card from a bank, when we buy to a store to buy something, usually this transaction has to go through some sort of an intermediary to approve it. In Cyprus, for example, all the banks here, they have formed the JCC, this is what it's called, company that is the trust, let's say, party, the central trust party between the various banks. With the use of blockchain technologies, these intermediaries, these central trust authorities are being removed. I agree with you.
Mm-hmm. Look, I think.
Yeah, you can start, I think.
Sorry?
You can start, I believe, in the next.
Yes, but I will need to see what participants are posting. So there are two solutions for this: either to have one of
What
the
we take them at the end. They write them here in the chat, and we take them at the end.
Probably, I would suggest a different way.
Mm-hmm.
When a critical point is being discussed, to see if there are any comments. So what do you think? And
sure, I can monitor that. Valentinos and I will be monitoring that.
Mm-hmm.
So we can interrupt you.
So actually, this is also would be very useful from the presenter side. So I'm ready to share my screen. I'm sure. Can you see my slides? So section 3, characterization of blockchains. So I would like to start this this part by asking from my side a very quick question. If you believe that a single monolithic blockchain implementation fits all the purposes for use cases such of those discussed before. Any ideas on this? For example, do you believe that only Bitcoin blockchain is appropriate for solving every type of problem in the industry? Let's say the supply chain industry. So as I'm seeing no suggestions, at least for now, let's say the short answer, which is definitely not. And this is because different types of applications require different types of blockchains in terms of functionality. So overall, there are three main categories, namely public, private, and consortium blockchains. Regarding the first category, as a public term suggests, we have largest interoperability, we have advanced security mechanisms in terms of the data protection, the transaction protection, and in general, there are, statistically speaking, I mean, in terms of applications deployed, they are more appropriate for a global deployment and adoption. Now, the private type of blockchains is, I would say, a restricted version of the public ones, where certain limits are set. This type is suitable for companies. And one benefit that comes with private blockchains is the fact that the maintenance costs are typically less compared to the public use case, because the investment, let's say, on the security front are not so significant, because the network by design is private. Now, the consortium characterization, I think, is lies somewhere in the closer to the private end of the spectrum. And the basic characteristic of this type of blockchain is that certain organizations forming a consortium are controlling the blockchain. Now, of course, those organizations should be trusted by all, and the use case of supply chain is a great example. So these are the basic definitions, and I would like to ask if there is any question with regards to those categories. So more details about the different types of blockchains as mentioned before. So regarding open blockchains, anyone can leave the network. Of course, first of all, join or leave the network. Anyone can validate the transactions, or if the network supports the creation of coins, anyone can create new coins. And the only technical requirement is just download and run this software. I think the most typical example is Bitcoin. Regarding the public dimension of blockchains, and this is a very, very important characteristics, transactions that are publicly verifiable and available to all in the network are feasible. This is, I would say, the cornerstone of public blockchains, and this is the cornerstone that enables digital payments. And probably this is the answer about my very, very first question, which is the right now probably the most important use case of blockchains. The answer is digital payments that support such level of transparency. And of course, Bitcoin is the very first use case. Do you believe that there is another use case, application, if you like, that can be compared to the case of digital payments, meaning that is equally important? So I would say that at least for the first generation of blockchains, which is determined by the type of applications, the digital payments is the most important one, which of course served as a motivation for considering other applications more advanced, require a richer flexibility in terms of technical capabilities, like the ability to program things using smart contracts to emerge. So as far as the very first generation of blockchain is being considered, digital payments is the most important application use case wise. Now, regarding the comparison between public and private blockchains, So actually, this distinction is defined regarding the access to transactions. So public blockchains give a wider set of access compared to private ones. Now there is this is a quite open research question: is what is the most appropriate proof consensus algorithm with regards to the type of the blockchain? Probably proof of work is the most appropriate for public and open blockchains. However, this is not always the case for other types of blockchains. For example, going back to the private type of networks, here proof of work is not always applied. And I would like to, again, ask a question. No need to answer this question right now, no need to share your view. We may save this question for a later discussion. If the question is, why do you believe proof of work is not always a good choice for private network? And the answer, and the short answer here, is that the proof of work is a computationally costly algorithm, and this is specifically designed as such in order to enhance the security of the network. And this is required because the network is by definition open and public, which enable access and transaction visibility to all, combined with the ability to generate new coins. So such openness require a certain level of security, and this is provided by proof of work. Now, if we consider a different type of blockchain being not so open, then the technical requirements about the security change. And probably a different type of consensus algorithm is required. And just to give an example, for the case of a hyperledger, where a more or less private setup, a network configuration is being used, a variant of proof of authority consensus algorithm is used there. So the take-home message is the type of consensus algorithms depends on the type, first of all, on the type of the underlying blockchain. I think that this is quite clear and makes sense. Correct? Mm-hmm. So, few more things about the Bitcoin blockchain, the Bitcoin actually network, a peer-to-peer network. Anyone can join or leave the network. Anyone can validate transactions or even mine new coins, which is incredible in terms of functionality provided openly to all. Anyone can maintain a copy of the entire blockchain and operate as a full node. This ability is what makes the entire peer-to-peer system robust. Also, is what makes the entire system secure, because there is no single central copy of the network. There is a copy. There are numerous copies of the network being distributed around the globe. and this is excellent. So having such capabilities, all recorded transactions are publicly verifiable and available to all network participants. There is no need to apply for credentials like IDs, passports, etc. in order to join the network. There is no need to go to a central authority and present those credentials and ask for approval. Also, the network operators are unknown to each other, and they, by definition, no need between the network operators is required. And one may ask, but how, without having trusted interacting partners, we achieve trust? And the answer to this is the way the consensus algorithm works. So by entering into this network, in practice, there is no need to trust others. However, the mechanism of the network itself makes sure that a certain level of trust is built once the network operates without, this is done implicitly. And of course, one of the application-wise of the most interesting aspects of the Bitcoin is the ability to have a native token. So instead of having a network and then trying to integrate a token with the network, we have a network that comes with a native token. Application-wise, this is excellent because you can very, very easily use this type of network for performing financial transactions. And a few words about consensus. Bitcoin uses proof of work, and Ethereum is trying to migrate from proof of work to proof of stake. Now, Ripple is a different type of network where permissions are required in order to join the network. So this is a different use case. So just to give the basic idea here is that actually you may join after approval the network, but there is another level of authorization in order to be one of the nodes that validate the transactions. You need to be included within the UNL, the unique node list, which is even more difficult. So there is certainly, I would say, a multi-level permission network. The key characteristic of the unique node list, the UNL list, is that only the votes that come from the members of the UNL list are being considered for validating transactions. I think Ripple is another excellent example of permission blockchains. And of course, Ripple comes with a native token, XRP. Hyperledger is a family of projects hosted by the Linux Foundation Blockchain Initiative. I would say that the most technologically mature and well-tested project here under Hyperledger family of projects is the Hyperledger Fabric blockchain, which is closer to the private networks. However, one key characteristic, technical key characteristic of Fabric is the fact that enables the configuration of the key mechanism used, including the consensus algorithm, which is, as explained before, quite useful because the application, the selection of the consensus algorithm depends on the target application, on the target use case. By default, Hyperledger Fabric provides an implementation of the Raft consensus algorithm, which is, I think, is widely acknowledged as the, let's say, the father of all consensus algorithms for the case of distributed systems, and it was proposed. The interesting thing is that it was proposed before the blockchain era. So the take-home message here is Hyperledger Fabric, that is the major product of the Hyperledger family of projects, is the most indicative and well-tested example of consortium private / private blockchains. And one of the attractive features of these blockchains is the fact that gives a certain degree of configuration flexibility to the developers. Any question about the differences between REPL and Hyperledger Fabric? I would say that Hyperledger Fabric is more flexible from a technical point of view. And another key characteristic and difference compared to Hyperledger REPL is that in contrast to REPL, which comes with XRP crypto, Hyperledger does not have a native coin. However, through smart contracts, you can implement one. Any questions up to this point? I'm checking my chat. Great. It seems that everything is clear. So this is a list that can be used as a short guideline about the selection of the appropriate blockchain. And the question is public or private, permissionless or permission, or something in between. The safest way to proceed in such considerations, I mean, when we are designing or when you are discussing about which type of blockchain to use, the safest way is to have even a basic understanding of the different options that are enabled by each blockchain type, and then proceed to a thorough discussion about the desired functionality of the end application. This thorough discussion will guide you about which blockchain type is the appropriate one for your use case. This is always the case, and actually this is what is done in the world of, let's say, traditional databases. First of all, you are considering what is being available by the candidate database systems, and then you are trying to map those functionalities to your desired functionality in terms of an end-to-end application, with emphasis on the functionality provided to the end users. So, in other words, the same process is also being followed here. And this is a link for more info about permission on blockchains, which come with a rich set of features. There are numerous blockchains in the literature, and the explanation for that is that because different variations of permission blockchains are needed for different functional characteristics, the plethora of use cases out there in the industry dictated the proposal of different permissioned blockchains. So, in other words, the number of permissioned blockchains is significantly larger compared to the number of truly open and public blockchains. So before entering section 4 about how we can move from a nice data structure like a chain of blocks to something more interesting in terms of functionality, that is how to move from blockchains to dApps, to decentralized applications, I would like to ask you, and checking the chat, if there are any questions, comments, ideas about section 3. Manuel, Sula, Simone, everyone, any ideas, comments?
Thank you, Leah. Okay with what you have presented. So I don't have any questions. I'm not sure if our audience has any questions.
Well,
I guess not.
Great. Well, that's
we have questions, yeah, in the Q&A section.
Mm-hmm. Sorry, Manuel, go ahead, please.
In the Q&A.
In the Q&A section,
we have one question.
Let me Q&A. I'm not seeing something.
What is, okay, let me tell you the question, Ilya.
Great.
What is the average cost of using a permission blockchain network?
That's a great question. So
yes.
Let's try to break down this question. So there is the cost in terms of software, that is by software, by the implementation of the blockchain itself. It's the cost of buying the hardware for running the blockchain, and is the cost of hiring the right people to use that software. So there are at least 3 questions. So which one?
If I may add, as you said, human resources, for the development of these types of technologies, because right now there is little expertise around. This is the cost is relatively high in that area as well, as you mentioned.
So I fully agree with you, Sula, and I would like to, while waiting for clarification on the initial question, let me try to share the answer in terms of magnitude. So software, I mean, just to have the blockchain implementation is typically zero, let's say €0. Now, the appropriate hardware, the magnitude for buying the appropriate hardware is from few thousands up to, let's say, tens of thousands euros for buying the machine or for using services like Amazon Web Services. However, what's more expensive is hiring experts, as you mentioned, Sula. So in other words, software is being provided for free, and the reason is because if we go for open public blockchain implementations like Bitcoin, this is open to the community, quite expected and reasonable. If we go for private blockchains, companies or foundations there, because they are providing this in many cases because they are giving this this to the people in order to foster adoption. So software and hardware are the cheapest, I would say, constituents, factors in this equation. What costs more is not only, is not only to hire the right people, because what Sula mentioned is absolutely true. There is a hidden cost to invest time in your existing and new team. You need to bring in new people. You need to give them the flexibility and the room in terms of time to develop and experiment with those new ideas. But you need also to build a culture in the existing team. Just to give you an example, do you think it is always easy to convince your, let's say, database expert, existing database expert, your existing database management team to consider migrating a part, if not the entire thing, a part of your data management system to blockchain? This means time. This means paying people doing experiments, means paying people changing processes, mean invest time for your entire group or team in order to be to adopt, become familiar with these new advancements. So this is, I think, a pretty high level generic answer to this question. So again, software and hardware is close to zero compared to the other types of costs. I don't know if we have managed to cover this question. Just again, looking my chat. You may also share with me those questions referring to, I don't know, Manuel or Valentinos. Yes? Let me ask a related question. Assume that you are the CEO or the CTO of a team, IT team. There is no need to mention explicit figures, numbers. We can do this relatively. So my question to you, assuming that you are leading a team, a business, what's the percentage of team's time, or what's the percentage of the budget that goes specifically to the IT team? What's that percentage that, under your capacity as a CEO or a CTO, you are willing to invest in exploring blockchains for your team. And at this point, I would like to see the percentages from your side. So yes, please share with me or with Manuel in QA or chat to see your view. And this is, of course, in relation to the previous question. Let's start from, I don't know, Manuel, just to give an example here. Personally, if I was leading such a team, I mean, being CEO or CTO, I would say 10 to 15%. 15% of the time slash budget that goes specifically to IT projects. And this 15% is for the very early phase. In other words, I would say to my key members of the IT team, okay, you may take almost a full day out of the 5 weekdays to experiment a bit with this new type of technology. Of course, always having in mind how this new type of technology can be integrated with our current needs. So my number is, let's say, 15%. And what's your number? I think that you are trying to figure out how to do this calculation. So while waiting for your estimation, let me proceed to the next section dealing with the migration, the advancement, I would say, from blockchains to dApps, which stands for decentralized applications. So first of all, let's quickly see what are the main characteristics of cryptocurrencies, which, as it was mentioned, constitute the main use case of blockchain technologies. This was and continues to be the first and one of the most important applications of blockchains. So cryptocurrencies change the traditional environment of heavily bug-based transactions. So just to briefly mention some of the key properties, they are permissionless. Anybody can download the software and conduct such transactions. They are irreversible, highly secure, instantaneous. Of course, let me clarify that the time required for a transaction to complete and clear depends on the blockchain used. For the case of Bitcoin, this time is 10 minutes on average. Things are faster for the case of Ethereum, and there is a satisfying degree of pseudo-anonymity, to put it correctly. Nothing is fully anonymous on blockchain, even in public and open blockchains like Bitcoin. However, if your business is it's okay from a legal perspective, so even this pseudo-anonymity works fine for you. Okay, the detailed presentation and comparison of the cryptocurrencies, I mean, is not typically speaking feasible within the duration of a presentation like this one, because we have literally thousands of cryptocurrencies, and the reason is the reason for having such huge numbers is the fact that this is programmable money. The only thing you need to create such a cryptos is software like Bitcoin blockchain. I'm not saying that the design and development and use of this software is, trivial. That's not. However, if the required technical expertise is in place, then you can relatively easily create a cryptocurrency. So here we are just mentioning the most important examples, including Bitcoin, Ethereum, Litecoin, and of course there are many more. Mining refers to the process the Bitcoins are being created. In summary, this has to do with the computational power a coin miner is willing to spend, and this computational power is spent in an attempt to solve a computational task that has to do with cryptography, and this combination of operation makes things in terms of security quite reliable. I mean, this process is what makes Bitcoin secure. And the transaction fees is a small amount, which is not fixed, of course, which is given to the miners for their effort to create a new coin. This is an interesting example of how Bitcoin prices have changed over the last decade. I think the trend is quite clear. A noticeable data point is the price that corresponds to the December's price of 2017, almost $20,000. The main message here is that from my side, from my interpretation, is twofold. Things tend to indicate that Bitcoin is a serious example of cryptocurrency, probably the most important one. So probably is going to last for X number of, I don't know, years. However, forecasting is not trivial. And I would say that Bitcoin is an exception. As mentioned in the previous slide, there is a huge number of cryptocurrencies. The vast majority of them will disappear. However, the focus here is not the cryptocurrencies considered as an investment vehicle. The focus here are the cryptocurrencies as the medium for the first application based on blockchain. So some phenomena like halving, etc., occasionally affect the price of cryptocurrencies, like the halving of the recent halving of Bitcoin's price. However, as briefly explained later, forecasting is not trivial. Forecasting techniques, the classical forecasting techniques, cannot always be applied for the case of cryptocurrencies because different background, I would say, phenomena affect the price. So please always, when considering using a crypto, please do a thorough background check and ask for professional advice. I think we have already seen the relation between Bitcoin and cryptography. So the key topic of this part of the presentation is that cryptography is the underlying mechanism for securing your Bitcoin address. You can consider Bitcoin address being an equivalent digital representation of an identifier, which is like your PIN number provided by the traditional banks. And this is an example of how a Bitcoin address looks like. Based on this representation, we may have alternative encodings like the QR code and similar things. And of course, you can share this address with any transacting party for your transactions. Please keep in mind that Bitcoin blockchain is not fully anonymous. It's close to what we call pseudo-anonymous. I would like to move to the wallets, to this part, to say that a wallet is an application that enables you manage your addresses along with your funds. I would say that there are two types of approaches. The first approach is to have full control of your wallet by downloading the blockchain, by downloading and using the blockchain itself. Usually, a blockchain implementation comes with a basic software that enables the management of your account and your funds. If this is not always user-friendly and requires a basic level of understanding of technical topics, and of course some understanding of programming languages. And the second option, which is widely adopted, is the use of third-party solutions that comes into two variants, having software-based wallets, like applications that can be installed on your desktop or on your mobile phone, or even a better approach, flavor is the use of hardware wallets, where specifically designed devices like Trezor enables higher levels of security. A common format for those devices is to take the shape of a memory USB-based stick. In any case, you need to protect and secure your wallet because things here, at least for the case of open and public blockchains, things are completely decentralized. There is no central entity and authority behind your account and funds, so you have 100% control and, of course, accountability of your funds or addresses. If you lost something, then this is gone forever. It is not like the case when if you lose your credentials, you can call a bank asking for a solution. Here, things are controlled by you, and this is especially true for the case of open and public blockchains. And paper wallets is another way to store your required credentials. Cryptocurrency exchanges are online third-party services which provide a wide array of services, including having online and managing online your wallets, along with a cryptocurrency exchange. By the cryptocurrency exchange, we refer to a service that is similar to what we already know in the traditional banking sector, where, for example, you can exchange US dollars for euros, etc. This is, by analogy, possible for the world of cryptocurrencies, where you can exchange cryptos, for example, Bitcoin for XRP, XRP for Ethereum, etc., etc. I would say the weak point of such third-party exchanges is the fact that they introduced a degree of centralization, because your exchange transaction depend on the availability of a third-party service. Examples include Binance, Kraken, etc. And here we have some basic comparison between centralized and decentralized exchanges. I think the first one, the top distinguishing feature is the centrally governed versus no central company feature behind the two. Any questions about centralized versus decentralized exchanges? And if not, I would like to go directly to the smart contracts, which constitute the technology that makes possible the creation of, first of all, cryptocurrencies, and on top of cryptocurrencies, more complicated applications that are based on the use of smart contracts for building other type of services. So as for the case of Bitcoin blockchain, the building blocks of this technology was known before Satoshi Nakamoto's paper. Actually, an interesting description of smart contracts was proposed by Nick Zappo during the 19th. So the key message here is that smart contracts are computer programs that run on the blockchain, and they are tightly coupled with cryptocurrencies. That's all. I mean, it's not easy, but this very brief description, I think, gives a solid, short, and solid description of what smart contracts are and what is possible with smart contracts. Any questions about this definition of smart contracts? Let's see some other characteristics of smart contracts that derive from this basic property. Smart contracts can automatically enforce power equality of all parties involved, can eliminate the possibility of any signatory defaulting on their obligations. Of course, they facilitate trustless and predictable transactions. They reduce human intervention, reducing the possibility of human error. So in this example, we have two transacting entities, and in the middle, we have the technology layer that makes this transaction trustful, which is, of course, the blockchain itself as a data structure that provide the low-level layer for blockchains to run on it, where the business logic of this transaction is being implemented in smart contracts. Just a brief mention of possible applications of smart contracts is clearing and settlement of any type of operation, like paying about your mortgage when buying a house or something similar from someone. Again, there is no need to build trust between you and the other party. This is programmatically handled by smart contracts. Smart contracts are the code just explaining the figure here. Smart contracts is the software code that runs on the blockchain, while TAP is something more broad and includes the graphical user interface plus other things on the periphery that, of course, interact with the smart contract itself. Now, decentralized application at the end of the day is it's a piece of software. There is a certain cost for running the application. There is a certain cost for setting up a team for creating and maintaining this type of software. As explained during my answer to the previous question about what's the cost of having a blockchain in your team, there is a time dimension, which is a key aspect of those applications. You need all operations completed within a time horizon that makes sense application-wise, and of course has benefits with regards to the user experience. For example, one of the time-related limitation of Bitcoin blockchain is the fact that on average 10 minutes are required for a transaction to be confirmed. If you are buying a coffee, 10 minutes is not an acceptable time frame for you to grab your coffee and continue probably your daily schedule. However, 10 minutes is acceptable when you are buying a house. So another way to put this is that the time that is required for a transaction to be confirmed should be always considered with respect to the application we have in our mind. Privacy is a huge area, especially considering the relatively recent GDPR directive. So smart contracts are pieces of software. The possibility of software bugs is always there. The possibility for data-related bugs is again always there. The good news is that you can hire a special team, even if you don't have the in-house expertise for checking thoroughly your smart contract. There are services available out there which are focusing on what we call smart contracts auditing. It's like hiring an auditing firm for checking your financial, your accounting department. Likewise, you can hire such experts for not developing your application, but to thoroughly check from a security point of view the security aspects of your implementation. And this part concludes with a long list of resources for further reading. And at this point, I would like to take questions, hear your comments, your ideas, anything you find relevant and useful for our discussion. So please feel free.
Well, it seems that everything was crystal clear, Ilya.
Glad to see this. Probably at the end we are going to hear more.
Yes.
So yes. So again, the floor is yours, Sula.
Thank
you.
I
think section 5 is probably the most interesting one because you are going to present use cases now.
Yes, a couple of use cases actually. Yes. Even though we do have, there is a large portfolio of use cases that will be presented in the rest of the modules also. Here I just wanted to give a flavor of them. I guess I need to be the presenter now.
Yes.
Valentino, Ilya, you have to stop sharing your screen, I think. All right, now I can share mine. I guess it's this one. All right, here we are. Wrong one again. Let's go into the display. Swap. Is it okay now?
Yes.
Great, thank you. All right, so here in this last section, we will be discussing some of the use cases that we have in regards to blockchains. As we have already mentioned, blockchain technologies can be applied in a wide range of industries, those ranging from financial services to accounting and auditing, to digital rights management, property ownership, issuing certificates and verifying their authentication, in maritime and shipping logistics, in energy management, in the government, and many more applications. I will mention a couple here, but they have been actually implemented. The first one that we see is in the food industry. It's a use case by IBM, Dole, Driscoll, Kroger, McCormick, and company Nestle, and Tyson Foods, Unilever, and Walmart. What these companies did, in collaboration with IBM that provided the technology, Hyperledger technology, they used the blockchain technologies to trace actually food, contaminated food. It has been statistically proven that every year we have about around the world 400,000 deaths that are being caused by contaminated food. So all these different companies that they deal with food, they're in the food industry, they implemented the technology to be able to trace contaminated food that was and prevented further illness. Actually, another benefit of this was lost revenue, and no products were being wasted. And the system was based on supply chains, being able to trace through a supply chain-based system the food and identify which one was contaminated or not. You can find further information on this on the link provided. Another use case in shipping, IBM and Maersk, one of the large shipping companies around the world, they tested a pilot case, again with supply chains, for avocados shipped from Mombasa to Rotterdam. And they estimated that their shipping carriers, they could save up to $38 billion every year if they automated through blockchain technologies the supply chains. Maersk aims to get, they have a total of about 70 million containers, and they aim to be using, to have the 10 million of those containers to be using blockchain by the end of the year. And again, more information can be found on the link shown here. At the University of Nicosia, another use case that we have been dealing with is actually the issuance of our certificates on the blockchain. And this prevents the falsification of certificates. In other words, our students looking for employment, and the employers require an authentic certificate. The employer themselves, they can authenticate the certificates via the application that we have here at the university. And we have other collaborators on that. Other universities are collaborating with us in issuing their certificates on the blockchain. The next section, actually, it's actually on it's questions that I believe it would be better if you answer them yourselves, so that we can discuss them at a later time together if you wish. You can always send us also any inquiries that you may have. We will also upload the answers in our Moodle, in the platform that we will be using for having these presentations online also for your future reference as well. And we will need actually your answers to be able to provide the certificate at the end of the course. Some final takeouts. In terms of blockchain, what you need to remember is that blockchain is actually a shared ledger that enables the various participants in the network to see all the transactions. It's a technology that enables decentralized, secure transactions without trusting a third party. So unknown parties can just trust each other. The transactions, they're placed into blocks which are linked together by one-way hashes, and thus they form the blockchain. All the transactions are append only, they cannot be modified, and they're cryptographically secured. A blockchain operates in a peer-to-peer mode, and each peer address is anonymous. And I forgot to make it into screen mode. And again, I need to go into this. All right. I think this is much better now. In terms of Bitcoins, Bitcoin, what we need to remember is that by the word Bitcoin, we refer to the whole concept or concepts and technologies that form the basis of the digital money ecosystem, that include this decentralized peer-to-peer network enabled by the blockchain by the Bitcoin protocol, a public, it is a public transaction ledger, and a decentralized mathematical and deterministic currency issuance mechanism, distributed mining based on various consensus algorithms. In terms of the Bitcoin, the proof of work, a decentralized system that enables transactions to be verified. Simply to remember this. We can look at blockchain as a decentralized data structure that allows, as we said, parties that do not trust each other to trust each other. And the decentralized trust it provides is based on cryptographic technologies such as the hash functions, the SHA-256 and the RIP MED 160, and public key cryptography as well. Three main categories of blockchain: public, private, and consortium. Public ones, they are the largest in terms of interoperability. They are censorship resistant, and they are good for applications that require global deployment. Private, we have lower costs than the public ones, since the validation does not have external threats, since we're talking about public, private network, and suitable for companies that deal with data from multiple branch offices. The consortium ones, they're based, of course, for organizations. They're suitable for organizations that they operate in a certain ecosystem, such as a shared database that is required to be trusted by the different participants in these ecosystems, such as, for example, in supply chains. cryptocurrency wallets, what we need to remember is that they contain the private public key pairs as tokens that enables the user to access their funds. And a smart contract is nothing but a contractual agreement that is implemented using code, basically software. Decentralized applications, computer applications that run on distributed decentralized systems that we call blockchains. Smart contracts are only a part of the whole decentralized application. Thank you very much. We have reached the end of this session. Of course, now feel free to ask any questions that you may have. Let me stop sharing. Okay. Do we have any questions? I think I see one here. No, I don't see any actually. Well, if there are no questions, I would like to thank you all for being here with us. Big thank you also to the organizers, Manuel and Audrey from USC and Insomnia. Manuel, I will pass the floor to you if you want to have some closing words.
Okay, thank you, Sula. Thank you, all the participants, for your attention. And I just want to reiterate that we will be asking you for feedback, and we will be waiting for your feedback during this week and in the coming days. So I hope that I have the opportunity to welcome all our attendees again tomorrow for the second session that will start with the learning module number 2 on encryption techniques, and will be delivered by Pablo Lopez, that will be provided by Insomnia. So just say goodbye to all of you and see you again tomorrow.
Thank you.
Bye.
Bye-bye.
Thank you, Sula and Elias, for these wonderful presentations. Bye. So, Valentinos, are you closing the session?
Yes, I'm gonna end it now.
Okay, so
For the recording to stop.
I stop. See you tomorrow.